Hi guys, well, for this video we're going to talk about fourth internal test paper. So the first question is, suppose you are given following data items to cluster, which is 2, 4, 10, 12, 3, 12, 20, 11 and 25, and the k is 2 using Euclidean distance computation. Apply k-mean clustering and generate the final cluster. Okay, so in the first iteration we take two values m1 and m2 on a random selection from all the between the data points that we are given here. There are data points here. You can see that 2, 4, 10, 12, 3, 12, 20, 11 and 25. We have taken m1 as 4 and m2 as 11. Okay, we have taken the value 4 and 11. You can see uh, in the points that there are data points as 4 and 11. So the initial cluster as C1 is equals to 4 and C2 is equals to 11. Now the Euclidean distances D is equals to x and A is equals to root over of x minus A to the power square of them. Okay, so D1 is the distance from M1 and D2 is the distance from M2. Okay, so as we can see in the above table, two data point is added to the cluster 1 and other data points is added to the cluster 2. How are we getting this cluster 1 and cluster 2? Here they have said the D1 is the distance from M1. Okay, so we are getting a point. We have taken this point 2 and the first data point was 2 and our right now our M1 is 4. So D1 is 2 and D2 is M2, so M2 is 11, so 11 minus 2, which is 9. Okay, 11 minus 2 is 9. So which one is the least in both of them? It is 2. We the value of D1, we would take the value of D1 because it's the lesser one in both of them. So the cluster is C1 because it is closer to both the number. If we take both the number and compare it with the both of them, I mean M1 and C1 and C2, we would get the we would if we take account of both of them, then 2 would be the least one, and so the cluster is C1. Okay, so by doing this we create we take account of all other data points. We would minus them, we would get the value. For 4 it would be 4 minus 4, so it is 0, and 11 minus 4 would give us 7. So again it is C1 because it's the least one. 0, right? So it is 0. 0 is the least in both of them, so C1. Then again we have 10. Okay, so 10 minus 4, so 10 minus 4 is M1 was 4, so that's why 10 minus 4 is 6. And for 6 D2 11, so 11 minus 10 is 1. So uh, here D2 is the least one. 1 is lesser than 6, right? So we would write here C2. Okay, and we do it accordingly, and then we get a value of C1 is equals to 243 and C2 is equals to 10, 12, 20, 30, 11 and 25. Okay, so we got the values, we got from our first iteration we got some data points in clusters. Okay, so we got some three data points in first cluster uh, and the rest in the second cluster. Okay, next we would take the second iteration. Again we would for this iteration we would take the mean of those uh, clusters. Okay, yeah, here the cluster was 2 3 4 2 4 3, so we would take their mean and get the value as 3. Then so that 3 would be the new M1. The previous M1 was 4. For this iteration, the M1 would be 3. Then again, we would take the mean of the second cluster, which is 10, 12, 20, 30, 11, and 25. And so we would take the mean of it and get the value as 18. So this would be the new M2. The previous M2 was 11, now it shifts to 18. With respect to both the M1 and M2, we get the value of the new data points. Okay, so we will calculate the distance and update clusters. Okay, so again we did the clustering thing. We calculate all the distance and updated the cluster according to that. Now the new clusters are 2, 3, 4, 10, and 12, 20, 30, 11, and 12. So if we again for the next iteration we would take the mean of these 2, 3, 4, and 10. So we took the mean of it and got the value 4.75. Now this is our new M1. The last M1 was 3. Now the new M1 is 4.75. Again we would take the values of C2 and take the mean out, and then after calculating the mean we would get the value 19.6. So 19.6 would be the new M2. Before it was 18, now it's 19.6. Through this M1 and M2 we would get the values. Again we did some uh, you could say the we calculate the distance and updated the cluster according to the M1 M2, and got cluster C1 C2 C1 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 C1, and then C2 C2 C2. We with respect to this table we came to a conclusion of new cluster as C1 is equals to 2, 3, 4, 10, 12, and 11, and C2 is equals to 20, 30, and 25. Okay, then we go for our next iteration, which is iteration number 4. Now we calculate new mean for data points in C1 and C2. Again we did the iteration in the same way. We took the now new clusters and took the mean. There we calculate the mean. We got a value of 7 and the value of 12. Now again we calculated the value of the calculate the distance and updated our cluster according to them. Okay, now we can see that the clusters are consistent for both the iterations. Now for iteration 3 and iteration 4, the cluster are same. Okay, we got 2, 3, 4, 10, 12, 11 in the last cluster too. Yeah, okay. In the previous cluster it was the same thing. Again here also it is the same. Okay, so as it is the same thing, as we can see the data points in the cluster C1 and cluster in iteration 3 are same as the data points of the cluster C1 and C2 in iteration 4. I'm sorry, I didn't do here in iteration 4. It means that none of the data points have moved to other cluster. Also means that this is the centroids or the means of these cluster is constant. So this becomes the stopping condition. This is where we stop in this algorithm, because now we have the centroids of this cluster, and with this we got our clusters, which was C1 and C2. C1 was for 2, 3, 4, 12, 11, 10, 11, and C2 was 20, 30, and 25. Next question is consider the following transaction data. We have some transaction data: bread, jelly, peanut butter, bread, milk, peanut butter, and beer and milk. So our support is 30 and the confidence is 50. Okay, for input we had the support as 30 and confidence and 50. Okay, the firstly we would take the frequency items and how many times bread came. The frequency was 4, because you can count it here. There is bread 4 3 times in the first. Then in T1, T2, T3, and T4 we have bread. Okay, so bread came 4 times, and and the total number of transaction data is 5. So 4 by 5 is equals to 80% support. Okay, next we have jelly, which came only one time in transaction T1. So 1 by 5, which is equals to 20% in the support. Okay, then we have peanut butter. Peanut butter is again, now how are we getting our support, the support values 80%, 20%, 60%? it comes with the what they call it, the formula of support. Okay. uh, so peanut butter came three times in the transaction, in T1, T2, and T3. So 3 by 5, because 5 is the total number of transactions, 60%. Milk came two times again in T3 and T5. So 2 by 5, 40%. And beer again to T4 and T5. Okay. So these are the frequency for all the item sets. Item set. Okay. Now we take two items in the same. Like we have to take care of two items in the at the same time. So like beer and peanut butter came three times. Okay. Sorry, bread and peanut butter came three times. It is in T1, T2, and T3. So the frequency of getting bread and peanut butter is 3, and then 3 by 5, because that is the total number of frequencies. So the support is 60. Then bread and milk only came for like one time. Okay. Then bread and beer also came only one time, so 20%. uh, Peanut butter and milk came only 20%. Peanut butter and beer never came together, and milk and beer was never bought together. Was bought only one time, which is 1 by 5, 20%. As you can see, any of the support, if it is less than 30, it is not counted. You can see a little cross here. Any support which is less than 20, which is less than 30, is not considered. So we would take only the 80, 60, 40, and 40 ones. We would not take 20 as it is less than 30. That is the input support. Okay. Now in the again, oh sorry, frequency item set, again we can see that the support here is only in the first item set. We could see that three it is 60%, and all of them are 20%. And so we would not consider this 20% and 0, as our input support was 60, and it should be maintained. And so we would take bread and peanut. For rules, we have item set as bread and peanut. Confidence is in B. Okay. The support right now, what was the support of this? 3 by 5. And support of A, the confidence formula is support by support of A, which is A is here in this manner. Okay. A here is bread. So what was the frequency of what was the support of A, which was 80%. So we would take the 60% and the 80% and get the value of 75% here. Then peanut butter and bread. Confidence is now B to A. Okay. So 3 by 5 by 3 by 5. 3 now here the B is A is our peanut butter. Okay. So peanut butter came 3 by 5 times. Here you can see 3 by 5 times is equals to 60%. So 3 by 5 by 3 by 5, which is 100%. Okay. So we know that if anything, our input confidence was 50%, and so we can take both of them. We can take both of them as it is greater than our confidence, which was 50%. So 75% and 100% are considered. And so with this, we talked about the k-mean clustering and the association rule that we generated in the last question. uh, with this, the video concludes. Thank you so much.